Welcome to today's math lesson on graphing proportional relationships and interpreting the unit rate or slope from a table. Our do now is a worker uses 500 inches of steel wire to make 300 springs of the same size. At this rate, how many inches of steel wire are needed to make one spring? So I'm going to start off by making a woe chart. WOE, the W stands for the words or the unit rates in the problem. The O stands for the original numbers or the original rate. And the E stands for equivalent or equal to. So the units in the problem are inches and springs. And as you can see, those are the words that were annotated when we read the problem. And it was 500 inches to make 300 springs. And since we're trying to figure out how many inches, I'm going to put X to represent that unknown number are needed to make one spring, and one goes on the bottom. Now we can write our proportion. A proportion is two fractions that are equivalent to each other or equal to each other. Everything in the O column goes in the left side of the proportion. So we have 500 over 300. And everything in the E column goes on the right side of the proportion, so X over 1. Now that we have this proportion, we have to cross multiply and divide. So we're using the butterfly method. We have 500 times 1, which is 500. And then we have 300 times x, which is 300x. And now we want to get the x alone. We want to isolate the variable. So we're going to have to do the opposite operation to move the 300 to the other side. So 300x is the same thing as 300 times x. So the opposite of multiplying by 300 is dividing both sides by 300. So 300 divided by 300 is 1. So then we have x is equal to, and to simplify 500 divided by 300, we can actually cross out the two zeros here. So it just becomes 5 divided by 3. So 3 can go into 5 one time. And we're turning this improper fraction, 5/3 or 5 over 3, to a mixed number. So since they're equivalent, the denominators are going to be the same. 3 is our denominator. And then we have 1 times 3 is 3. To get our new numerator, we have to subtract the old numerator, which is 5, minus the 3. And so we get 1 2/3, which was answer choice J, 1 2/3 inches. Today's TEK is 8.4b. Our lesson target is that scholars will graph proportional relationships, interpreting the unit rate as the slope of the line that models the relationship. The DOL is given 4 problems. Scholars will graph proportional relationships with 100% accuracy. The academic vocabulary for today is the word rate of change, unit rate, and slope. All of these represent the same idea or same concept. So anytime you see rate of change, unit rate, or slope, you're finding the change of y over the change of x. And so this triangle right here is the delta symbol, and it represents change of. So change in y values over the change in x is how you find the rate of change, unit rate, and slope. And this 3-column process chart is what we're going to be using today to find our rate of change, unit rate, slope. In this example right here, we can see that our rate of y values is +4 or +4, because from 0 to 4 you had to add 4, and from 4 to 8 you add 4. From 8 to 12, you add 4. From 12 to 16, you add 4. And from 16 to 20, you add 4. So that's why our change in y values is 4. Our change in x values from 0 to 3 is adding 3. From 3 to 6 is adding 3. From 6 to 9, adding 3. From 9 to 12, adding 3. And from 12 to 15, we're adding 3. So that's our change in x values. So our rate of change, our slope, or our unit rate is 4 over 3. In this problem right here, it says every hour, 4 cakes are decorated. So we're going to fill out this 3-column chart. And before we do that, I'm going to write an equation given this situation. So y is going to represent the number of cakes decorated. 4 cakes are decorated every hour, so we have 4 times x, with x representing the number of hours. So in this chart right here, this is our x values, and that's the time in hours. This is our y value, which is the number of decorated cakes. And I'm just going to say 0, 1, 2, 3. And our equation is 4 times x. So in this middle column, I'm going to multiply 4 times our x values. So 4 times 0 is 0. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. And so the change in y values from 0 to 4, or the difference, is we're adding 4, positive 4. From 4 to 8, we're adding 4. From 8 to 12, we're adding 4. So our change in y values is we're adding 4. Our change in x values from 0 to 1, we're adding 1. From 1 to 2, we're adding 1. From 2 to 3, we're adding 1. So our change in x values is that we're adding 1, or positive 1. So we have 4 over 1 is our rate of change, or our slope, and that's the same thing as 4 divided by 1, which can be simplified to just 4, which goes back to the statement that says that every hour 4 cakes are decorated. And then in our equation, 4 was right in front of the x, because in proportional relationships, the equation is y is equal to k times x, and k represents the constant of proportionality, the unit rate, the rate of change, or the slope. This I do problem reads, given the x values and y values of a proportional relationship, find the following: the unit rate, the rate of change, the slope. Write an equation and graph the points. So starting with our y values, from 0 to 6, we're adding 6. From 6 to 9, we're adding 3. And so since our rate of change for our y's aren't the same, I can guess that our rate of change for our x's will not be the same, since we know that it is a proportional relationship. So from 0 to 2, we're adding 2. From 2 to 3, we're adding 1. So in this case, when we have our equation k is equal to y over x, or change in y over change in x, we can't say what the change in y is right now because it's different. It doesn't seem like it's consistent. So what we're going to do is choose a pair. So we're choosing 2, 6, and we're going to plug in what the y values and what the x values are. So the y value is 6. The x value is 2. 6 divided by 2 is 3. And I'm going to choose the other pair just to confirm that our unit rate, our rate of change, our slope is 3. So I'm choosing 3 and 9. So we're using the same equation, k is equal to y over x. Our y value is 9. Our x value is 3. We have 9 divided by 3 is 3. So now it confirms that our unit rate, rate of change, and our slope is 3. So from here, we can actually write an equation. So proportional relationships are always in the form y is equal to k times x. So we have y is equal to, our k is going to be 3 times x. So we have y is equal to 3x. So I'm going to rewrite our equation, y is equal to 3x. So the points in the table that were in the last slide have now been translated to this chart right here with the x values and the y values. And so now that we have our equation, we can fill out the middle part of the chart. So we have 3 times x. So we're going to multiply 3 by all of our x values. So when x is 0, 3 times 0 is 0. When x is 2, 3 times 2 is 6. When x is 3, 3 times 3 is 9. So our change in y values from 6 to 9 is positive 3. So I'm going to put that up here. Our change in x values from 2 to 3 is positive 1. So I'm going to put that as our denominator. 3 divided by 1, or 3 over 1, is the same thing as 3. And then I'm going to graph 2, 6 and 3, 9. So 2, 6 is right here, 3, 9 is right here, and this is 0, 0, or the origin, which was our first point. So from 2, 6 to 3, 9, I moved up 1, 2, 3 points, or 3 units, and then I moved 1 unit to the right. So this 3, our change in our y values, was our numerator. Our change in our x values along our x-axis was our denominator. So 3 over 1 is 3. Next, we have the simulation in Nearpod where we can change the 2 points and see how that affects the slope or the shape of the line. So right now we have 1, 2 and 3, 4. And so our slope is 1 because from this point to this point, we moved up 2 units and to the right 2 units. So we have 2 over 2, and 2 divided by 2 is 1. If we moved the point to, this is still 1, 2, and this is 3, 3, we can see that we moved up 1 unit and to the right 2 units. If we moved this lime green point right here, its coordinates is now 2, 6. We can see that from the 1, 2, we moved up 1, 2, 3, 4 units up and 1 unit to the right. So 4 divided by 1 is 4. So that makes our slope, our unit rate, our rate of change, our constant of proportionality 4. We have some we do problems. So the next I do problem has a different table, or a table with different values. And so starting with our y values, from 0 to 1 is plus 1. From 1 to 2 is plus 1. And from 2 to 3 is plus 1. From 0 to 5 is plus 5. From 5 to 10 is plus 5. From 10 to 15 is plus 5. So now to figure out our slope, we're finding our change in y over change in x. And so since the change in y values are all the same, we know that our change in y is 1, and our change in x values are all the same. So we know that our change in x values is 5. So our slope, our unit rate, our rate of change is 1/5. And from here we can write our equation. So proportional relationships are always in the form y is equal to k times x. And k just is the letter that represents the unit rate, rate of change, slope, or constant of proportionality. So to write the equation, we have y is equal to 1/5 times x. So I'm going to rewrite that equation on this slide. And all the values in that table have now been put into this chart right here. The x values on the left side, the y values on the right side. And we have our equation 1/5 times x. So what that means is that we're going to multiply 1/5 by all of our x values. So when x is 0, we're multiplying 1/5 times 0, which is 0. When x is 5, we're multiplying 1/5 times 5. And when we multiply fractions and whole numbers, we keep our denominator. So our denominator is still going to be 5. And we multiply the numerator and the whole number. So 1 times 5 is 5. 5 divided by 5, or 5 over 5, can be simplified to just 1 whole. So when x is 10, we have 1/5 times 10. When we multiply a mixed number and a fraction, we keep our denominator. So again, the denominator is 5. 10 times 1 is 10. 10 divided by 5 can be simplified to 2. Then when x is 15, we have 1/5 times 15. When we multiply that out, we get 15 over 5. 15 over 5 can be simplified to 3. So now we have to figure out the change in y values. So from 2 to 3, that was positive 1. So our change in y is 1. From 10 to 15, the change was plus 5, positive 5. So our rate of change, our slope, or our constant of proportionality, our unit rate is 1/5. Now we have to graph the points. So we have 0, 0, which is right here, the origin. Then we have 5, 1. So starting from the origin, I'm moving 5 units to the right, 1, 2, 3, 4, 5, and 1 unit up. Then we have 10, 2. So starting at the origin, we're moving 10 units to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 2 units up, 1, 2. And then lastly, we have 15, 3. So starting at the origin, moving over 15. So if this was 10, 12, 14, 15, and up 3 units, 1, 2, 3. Now I'm going to draw a line to connect the dots. And on this graph, using this first point 0, 0, and the second point 5, 1, I can visually identify what my slope is by seeing how many units I'm moving up. So I'm moving up 1 unit because this is our y-axis, so that was our change in y, which became our numerator. And then I'm moving 1, 2, 3, 4, 5 units to the right, which was our change in x, which became our denominator. So that is how our graph looks with a slope of 1/5. In this Nearpod lesson, there were several we do problems as well as you do problems. I will include the PowerPoint with the solutions to these we do's, these you do's in the description box. Now it's time for the DOL. It's a 4-question DOL and it's a Google form. So thank you so much for following along and paying attention in today's lesson. I will see you in the next math video. Bye.